Hello viewers, on special demand of some of my viewers, I am making this video on working models and projects. This is the working model of a burglar alarm which is based on the property of rectilinear propagation of light. Here I am using 3 mirrors, one laser light, one battery, one alarm and one small circuit along with the sensor. As soon as I switch on the key, it means current start flowing in the circuit. The ray from this laser light falls on the first mirror, and due to the property of reflection of light, it falls on the second mirror and then on the third mirror and then to the sensor. It means circuit is complete. Now, if any outsider wants to enter in the premises of your house, this burglar alarm will ring. He or she might enter from any of your boundaries, so this will ring on all the other sides also. As you can see here, whenever there is obstruction in the flow of current, this burglar alarm will ring. This working model represents hybrid cars, which are powered by an internal combustion engine and one or more electric motors, which uses energy stored in their batteries. Hybrid cars are not charged by plugging into the current. Instead, the battery is charged through regenerative braking and by the internal combustion engine. This extra power provided by the electric motor helps to increase fuel efficiency of the car. As you can see, this car is running. When we apply brakes, it generates electricity. As you can see, this LED is glowing and it means power is generating. And this generated power is stored inside the car, and this is how this hybrid car becomes fuel efficient. This is the working model of a Tesla coil, which is an electrical resonant transformer circuit designed by inventor Nikola Tesla in 1891. It works on the principle to achieve a condition called resonance. Here, a primary coil emits a huge amount of current into the secondary coil, and the fine-tuned circuit helps to shoot the current from the primary to the secondary circuit at a tuned resonant frequency. Here we are using a motherboard, a transistor with heat sink, capacitor, resistor, infinite number of turns of this copper wire on the PVC pipe, power supply and this CFL. As soon as I switch on the current in the circuit, by pressing the key K, you can see the current from the primary coil shoots and jumps to secondary circuit at a tuned resonant frequency, and you can see this CFL is glowing in my hand. Now visibility is more clear in this dark mode. This is the working model of automatic solar rotating panel. This system can be used to store solar energy and utilize it for powering devices. In this project, I have used one solar panel, LDR sensor, PC motor to adjust the orientation of solar panel. This solar tracking system maximizes solar system's electricity production by moving our solar panel to follow the sun throughout the day, which optimizes the angle at which panel receives solar radiation. As we all know, the sun's position in the sky changes with seasons and with the time of the day. Solar trackers generate more electricity than their stationary counterparts due to an increased direct exposure to solar rays. Solar panels cannot produce energy at night but can work even in the rain when light is reflected or partially blocked by clouds. So now I am going to demonstrate the working of this project in the absence of light, and our light source is using as a sun, which is the primary source of all the energies on the earth. As you can see, sun rises in the east and solar panel rotates along with the sun. With the help of this motor here, when the sun in the noon time comes on the head, it takes its position along with the sun. When sun sets in the west, It comes along with the sun in the western side, and the whole day you can take efficiently all the solar energy. I'm sure you have liked these setting models. If you have any doubts regarding their construction, you can tell me in the comment section. Further videos, I am going to show you some more exciting models and projects. Thank you.